Hey, what's up guys, welcome back to Eureka, and in this video, we'll be starting chapter 2 of the mechanics book level M, which is displacement and distance. Now, from grade 10, I hope that you remember the differences between those two and how they're represented, because this is literally the whole section is just talking about the differences between displacement and distance. But nonetheless, I'm going to show it to you again. Say that this is your coordinate axis, right? This is your positive x-axis. Now, in this chapter, we're going to be analyzing motion along a straight line. That means we're going to be analyzing one-dimensional motion. That means your particle can only move in one direction. It can't move freely on a plane or freely in space. Just it's bounded on one line, right? That's what we mean by one-dimensional motion. Anyways, so you define an origin. This is your origin, right? Denoted by O or 0 or whatever. This means that you will measure distances or displacements from that origin. This is your reference frame. Because I can define my position right now. I can say, okay, it is, I don't know, 5 meters from the table, 2 meters from the chair. But like, I can also define my position as, I don't know, 10 meters from the kitchen or something, right? So we need some origin so that we can describe your position without having to contradict yourself. Because I might say, okay, I'm 2 meters from that, I'm 10 meters from that. That doesn't mean anything, right? So that's why we need this origin. Anyways, if I move, right, to this point over here, which I'll say is, for example, 5 meters, right? This is 5 meters from the origin. The distance you moved is 5 meters, right? You also displaced 5 meters. Now, what is this delta x over here? Now, x is your position, right? Because right now, since you're in 1D, we don't need vectors at all, right? So we don't need to write this vector notation, even though, yes, the position is a vector quantity, but for one-dimensional motion, you don't need to specify that, okay? Since we chose our point to move along the x-axis, we'll denote position by x, right? So this thing right here is the position. The triangle, I'll draw it better. The triangle means a change in something. If you change your position, you displace yourself, right? You move. This letter is denoted by a capital Greek letter called delta. It's capital, okay? The small delta looks something like this. Moving on. So, from here you can see that in this case, distance and displacement, yeah, they're the same, but is that always true? I'll give you another example. I'll erase all this, right? And I'll say that I moved, I don't know, this is 10 meters to the left, right? So I should put a negative 10 over here, right? The distance will be what? Will the distance be negative? Distance is always positive, right? It's just the, distance between 2 points. It can't be negative. That means distance will be 10 meters. But did you displace 10 meters to the right or to the left? Because we define positive to be to the right, if we move to the left, you will displace yourself 10 meters to the left. This green negative sign basically means you're going towards the opposite direction of your positive sense, right? That means you're going towards the negative sense. Okay, so we must know that distance and displacement, they're not the same. So can we make some more guesses about their relationships, right? We could guess that the distance is the absolute value of the displacement, right? Which will work in this case. I'll give another example that kind of contradicts this. I'll do another example. Say that I moved 10 meters to the left, and then I moved, let's see, 5 meters to the right. That means I will end up at negative 5 meters. So I started by moving 10 meters to the left. Then from that negative 10 meters, I move to the right 5 meters. My distance is the total distance traveled, right? First of all, I move 10 meters to the left, so distance is 10 meters, plus 5 meters to the right, which is 5 meters, right? Will be 15 meters. But how much did I displace? Now, displacement means how much did you move in total, right? You started at 0, you ended at -5. That means you moved 5 meters to the left. This is -5 meters. I'll write the definition of displacement later, but here's the idea, okay? So, from this example, you can see that distance is not necessarily the absolute value of x. Okay, so we can calculate the displacement, right, by just thinking how much did I move in total. Is there an easier way to do it? Yeah, there is. If we can define what displacement is, right? The displacement is defined to be the final position minus the initial position. This should make sense because your final position in this case is -5, right? In green. Your initial position is 0, right? How much did you move? You moved 5 to the left, right? Means -5. Or it is -5 minus 0. Another example. Let's say you start at 5 meters to the left. This is 5 meters, right? And then you end at, let's see, -10, right? Let me just erase all this. At -10 meters, right? How much did you displace? Since you started here and ended here, right? It's your final minus initial. Final position is -10, which is equal to -10 minus 5. This should make sense. This is -15. It should make sense because you moved 5 to the left to the origin, right? That's a -5. And then you move 5 to the left again, which is a -10. If you add them up, which is, just -10 plus a -5, that's still equal to -15. But this is a way for you to, understand what's going on. Okay, so this is the formula for displacement, right? We could generalize this to 2 or 3 dimensions, but that's for next chapter. Next chapter, we're going to make all of those equations a vector equation. You're going to change everything to vectors. But for now, just numbers is enough. But how can we define distance? Let's say that you start from the origin, move -10, right? -10 meters. Then you move all the way back to 5 meters, right? We know that the displacement in this case is 5 meters. Distance, however, is -10, sorry, not -10, 10 meters, right? Plus a 15 meters, which is 25 meters. But how can we actually, make a formula out of this? Notice that there are 3 special points, right? We have the origin, not the origin. In this case, we call it the initial position, right? Because we start at the origin. This is the initial position. Then you have a turning point. From the initial position, you go to -10. That's a turning point because you turn back, right? That is a turning point. And then this is your end point. So we have 3 special points. Initial, then you have the turning point, then end point. We could do this. We could say that distance is the absolute value of your first displacement plus the absolute value of the second displacement, such that all of those displacements are labeled by delta x sub I means 1 and 2, all of them, they have no turning points. They have no turning points. This will be your first displacement. It's a vector. Well, in this case, it's not. It's just a number, but we can visualize it as a vector. That's your first displacement, right? Notice that there are no turns. This is your second displacement. So basically what we need to do is you find all those displacements, okay? make sure that those displacements, they don't have any turning points. Then you take their absolute value, add them up. Let's try it. So distance will be equal to the first displacement, which is negative 10 meters, absolute value, plus your second displacement, which is 15 meters, which is equal to 25 meters. It's the same thing that we got before. Anyways, guys, I hope that you understand the differences between displacement and distances. It's absolutely crucial for you to understand this, okay? Because this is quite literally the simplest concept of this chapter. If you don't understand this, then please rewatch it or comment down below and ask us the questions, okay? And as always, easy.